Welcome to Aptitude Destination. Please pause the video and read the question completely. So two statements are given. Age of P and Q are each less than 100 years but more than 10 years. So I can represent it like that. If you interchange the digits of P, the number represents Q. So this is a rather easy way. For example, if I am taking the age of P as 12, the age of Q is 21. So it's easily understandable. What is the difference between their ages? So the first statement says the age of P is greater than that of the age of Q. Now this can take any value, right? There are n number of possibilities. Like I said, if I say P's age is 82, then Q's age will be 28, which is serving the statement where P is greater than Q. But I can also take 73, for example. This will give me 37, which is still greater. So there are n number of possibilities as such. So statement number 1 alone cannot tell me the difference between their ages. Let's go for the statement number 2. The sum of their ages, so P plus Q, is 11 by 6 times their difference, P minus Q. So here we know that P can take any value between, for example, let's say 15, 51, 14, 41, all these kind of values, 24, n number of values where P and Q can satisfy the first equation as well as satisfy the second equation. But for it to satisfy the second equation, we cannot keep checking each value of P and Q. Now what we are going to do instead of that is that represent P in the format of 10A plus B. This is nothing but a representation of any two-digit number. For example, if I take 38, I can represent it in the form of 30 plus 8. Furthermore, 10 into 3 plus 8. So this is A and this is B, and AB combined is 38, but the representation is 10A plus B, right? I hope this concept is pretty clear to everyone, because this is a basic concept of how to represent two-digit numbers, three-digit numbers, and so on. Now that we have represented P in the form of an algebraic expression, we know what the value of Q is, because they have said it's just the interchanging of digits. So if this is the tens place digit and this is the units place digit of P, then Q will be nothing but 10B plus A. I hope this concept is clear to everyone. So now we'll move on to the equation. We'll elaborate this equation based on this. We know that P plus Q is nothing but this, and here it's 11 by 6 into P minus Q. So P minus Q, we can substitute the same, which means 10A plus B is P minus 10B plus A is Q. So minus is common to both, which means minus 10B minus A. Now if I have to solve this, I'll be getting 11A plus 11B equals 11 by 6 into 10A minus A is 9A, B minus 10B is minus 9B. Alright, now we know that 11 is common in both the sides, so I'm cancelling out the 11. So let's take 6 to the other side, which means 6A plus 6B equals 9A minus 9B. So this will give me 15B equals 3A. Cancelling these out, I'll get A equals 5B. Now I'll have to find the digits which will satisfy both, which will satisfy this equation. So I think the only thing I can substitute here is 1, because this will give me 5, and this I can substitute as 5, because any other value, if I'm substituting, let's say 2, the least value after 1, it will be 10, and I cannot give A as 10 because A is a single digit. Therefore the only possible value is for B to take 1 and A to take 5. Now I can easily form the ages of P and Q. P was said to be 10A plus B, which means 50 plus 1, that's 51. and Q is 15. So without the help of the first statement where they said P is greater than the age of Q, we have found out the value of P and Q. Therefore, statement 2 alone is enough for us to find out the answer. So the difference between these two will be the answer, which we don't need to find. Do not waste time on that. So the question can be answered by using one of the statements alone but cannot be answered using the other statement alone. Option A is the right answer.